Assalamualaikum guys. Good afternoon.
Walaikum assalam, miss.
I can see Alia, you're only here. What is it with the rest of the girls?
I don't know.
They forgot to have a class. Okay, I can see Rama is coming. Okay, fine. So I'll start. I think the rest will also come within a minute. Okay. Do you remember girls? Yesterday we were solving 41 made to 19 and we reached the question number 7. Till 6 we have finished. So I want you to go to question number 7. 41 made to 19, question number 7. I want to check with you. Hopefully you have finished the question by the time, but I want to go to the checking the answers with you. Do you have it in front of you now? 41 May June 2019.
Yes, miss.
Okay, fine. So I'm doing question number 7 with you now. Just check. The question is about current electricity. They have given us a diagram, a circuit. State the name of the component X. So tell me first, what's the name of this component?
Variable resistor?
No, dear, it's not variable resistor. Look at the diagram.
It's a thermistor.
It is a thermistor, definitely. Variable resistor is having an arrow. It's not the arrow one there. You got confused by that. It is a thermistor. Correct answer. Now check the next part of the question. The electromotive force of the battery is E. They have given us capital E, just a symbol, no values. The switch is closed now. Okay, before that, girls, understand the circuit. Did you notice that 30 ohm resistor and the thermistor is connected in parallel? Right, girls? And then with that, 20 ohm is connected in series. So, can I just say that this potential, that is the EMF or the PD, is going to be divided among these two. Means the PD that will be across the thermistor and the 30 ohm resistor will be the same, and 20 ohm resistor will get another PD because it is acting like a potential divider circuit. So with that explanation, we'll come to this one. They say the potential difference PD across 30 ohm resistor is V30. So if it is V30, what about the potential difference across Vx, means the component X? What will be that? You can tell me, girls.
Equal to V30.
Exactly. So actually Vx and V30 will be the same because they do share a potential divider circuit and they are in parallel circuit. So if they are parallel, so both of them are going to have the same potential difference because they will be acting together in the potential divider circuit. So we have to say Vx equals to V30. Okay.
Assalamualaikum, miss.
Walaikum salam. Okay. Now, so part 2 of the question they are asking, what is the relationship between E and V20? So we can understand one more thing, that is the one that I wrote in Vx, that was V30. So Vx will be E minus V20.
Miss, are we doing the same variant for one?
Yes, we are in the same body. 41 May June 19. Question number 7 we are doing now. Excuse me, guys. Okay. So now we are in V2 and we got here that Vx, that is the potential difference across the thermistor, will be nothing but sorry. Okay. It will be nothing but E, that is the total EMF of the battery, minus that is the voltage for the 20 ohm resistor. So it will be the equation Vx equals to E minus V20. Is it clear to you now, guys?
Starting B?
Miss,
Yes.
Yes, say. Which we are done with.
Are we doing question B?
Yeah, we've finished B now. V1 is Vx equals to V30 and 2 is Vx equals to E minus V20.
Miss, are we doing question number B?
Mm-hmm. We're done with it.
How are we
Miss.
doing it again, Miss?
I told you. First question is B1 is nothing but Vx equals to B30. Because,
Yes, Miss.
yes, and then Vx equals to E, capital E, minus V20.
Why is it so, Miss?
Look at the diagram, then you'll understand that the component X, that is the thermistor, and the 30
Yes.
are going to have the same. And the 20 ohm resistor will have a PD of V20. So definitely Vx is going to get the EMF, that is E minus V20.
Right.
E is the total EMF in the circuit,
Yes, Miss.
and you have to subtract V20 from there to get the PD for Vx. Means that is for the component X of the thermistor.
Okay, Miss.
Now turn the page. You will get part C of the question, and they say the EMF of the battery is 6 volt, and the resistance of the component X is 50. Okay. First, they say calculate the total resistance of the circuit. As I told you initially, that if you look at the circuit, you'll understand that here a part is a parallel circuit, then it is added to the other part as a series.
Series circuit.
Yes. So first
So we have to calculate the parallel plus series.
exactly. First you do the parallel, that you have to write down the equation 1 by Rp equals to 1 by R1 plus 1 by R2. So for you it will become 1 by Rp equals 1 by 15, because the component X is 15, plus then you have the other component, that is a resistor of 30. So you'll be doing 1 by,
The total is 30.
yes, the final answer is 30, but after getting 1 by Rp equals to 1 by 10, then Rp equals to 10 ohm. Right, guys? Okay. And then you'll be going for the next step, that is we are having R equals to, means now we are going for the total resistance. R equals to Rp plus 20. So it is 10 plus 20 is 30 ohm. But do show all the steps. Okay, otherwise there's a mark given to you, 3 marks, you have to score the whole mark. So you need to show all the steps. Then guys?
Got disconnected.
Yeah, so shall I start again? Part 2 of the question, C2. So the answer of part 1, C1 was 30 ohm. As I told you, you show RP first, showing the calculation of RP. Then you have to add it with the series one, that is 20. Then together it will become 30 ohm. Done, guys?
Yes, Miss.
Okay, fine. Now come to C2. The
Are we going to use the
Miss.
I equation, I equals V by R?
Miss, I got 0.2 ammeter.
Ampere, 2 ampere.
Sorry, okay, ampere, sorry.
Yeah, 2 ampere, that's the correct answer. Fine. Now, read the next part of the question. They say the temperature of component X increases. Can you explain what happens to the ammeter reading? Now, girls, if you just look at that component, that was a thermistor. So they gave us 2 marks. You have to,
Ammeter reading decrease.
first of all, understand it, that you have to explain the behavior of the component X when the temperature got increased. Whatever component is that was a semiconductor device, isn't it?
Yes, Miss.
So
Yes,
we know
Miss.
that when the temperature rises, the resistance of that particular component will get decreased, and it will
Yes.
allow more current to go. But you have to understand one more thing, that it is connected with the other component, that is 30 ohm resistor in parallel. So as the temperature increases, resistance of X is decreases, and the total resistance of the circuit also decreases. Isn't it? Therefore, what will be the reading on the ammeter?
The reading on the emitter increases because the total resistance of the circuit, it will decrease. So more current will be flowing. So the reading should increase on the emitter.
Yes, yes, very good answer. So that is how you have to write down the whole thing. First, you will mention about the component X, then the total resistance of the circuit is getting decreased as well, and then the current passing through the ammeter will be increased because the circuit resistance got decreased. Right, girls? Okay, we'll just complete it, then we can move to question number 8. Okay, are you done with the question, girls?
Yes, Miss.
So let's proceed to question number 8. Okay, it's an electromagnetism question. And of course, it's nothing but a generator. So all of you look at the question one more time. If you're done with that, then you can read out the answer for me. First, if you just look at it, a student turns the handle on of an alternating current generator and the coils rotate. If you just look at the diagram, you can see that the coil, there's a handle. With the handle, they are going to rotate it, and it will start rotating. There is an alternating voltage output between the two terminals. The one that we showed output. Explain why the rotation of the coil produces an output voltage. Okay, what is your idea about the answer of this particular question, girls? Could you suggest me the answer for this question, girls?
The rotating coil, it's A1, right? The rotating coil, as it rotates, it will cut magnetic field lines, which will induce an EMF in the wire, in the coil. So current will flow through the wire, and this will produce an output voltage.
Okay, correct answer. But we just need to mention one small thing. What method is happening here? Could you tell me that method? Which method is going to produce this? Because you say that it is going to cut the magnetic field lines. But what do we call this method?
Is it No, not really.
Complete your answer. I want to hear that. Electromagnetic induction method.
Electromagnetic induction.
Exactly.
Oh, my mic wouldn't switch on.
Yes, just at that point, then it will be all right. First thing is that as it is rotating, it is going to, as you said, it is going to cut the magnetic field lines, and which is actually going to produce an EMF by the electromagnetic induction. That's it. And that is going to produce the output voltage, which can be found by placing a lamp or something. That one we don't need to mention. But the main point is that it is going to cut the magnetic field lines, and it is going to induce EMF by the electromagnetic induction. Done this? Shall I proceed to A2 now?
Yes, miss.
Okay. Take the position of the rotating coil when the alternating output voltage is at the maximum. Okay. Value and
When it is what is in vertical, when the coil isn't rotating, like kind of it's vertical to the magnet, because the field lines are being cut more.
No, I don't think so. You take the opposite answer. If it is a vertical, that time it is not cutting the magnetic field line. So why will it produce? So they say to explain why the maximum output occurs at this position. It is the horizontal position here. From horizontal position, it will start rotating. Then it will start cutting the magnetic field lines, and then it is going to produce the highest amount of that EMF, induced EMF. Okay, so you have to say like this: the plane of the coil should be in the horizontal position. The way it is at this moment in the diagram now. Okay, at this moment, the way they showed us in the diagram, that will give us the idea that it has to be horizontal to the magnetic field lines. Okay, and if it is horizontal to the magnetic field lines, then only it will start cutting more number of magnetic field lines. As then you can mention, as it will rotate, it cuts the magnetic field lines as the first test. Did you get my answer?
I didn't understand, miss. Why horizontal again?
When it is horizontal, from there it will start rotating, isn't it?
Yes.
So when it is rotating, then it will cut the maximum number of magnetic field lines. So that's how we are going to answer this question. So it will be horizontal position.
Okay.
Now I want you to go to the next stage. Then check the part B of the question. Then just check the next part of the question. A lamp and an open switch are connected. Open switch are connected. Okay, they're connected in series to the output terminal of the AC generator. The switch is closed and the lamp lights up. Okay, so the student has to apply a greater force on the handle. Explain why a greater force is needed to keep the lamp lit. Okay, now you tell me first. Why do we need to rotate it? First of all, you tell me, what was the purpose of rotating this handle? Do you understand? Why do we need to keep on rotating? If you don't rotate, then the magnetic field lines will not keep on cutting. And if it is not cutting, the induction process will not be continuous. So we will not get a continuous amount of electricity produced. So to produce the electricity continuously, we need to have this rotation. And if you keep on rotating it faster, or if you apply more force, it will move faster and it will produce more electricity that will allow this one to, this lamp to keep on shining. So you can write it like this, that due to the induced EMF, a current produced in the coil which experiences force in the magnetic field. Okay. Now, do you remember the latest law that I have discussed? That whenever a current is produced, it is going to create a force on it, because we learned that if the current is passed through a coil or through just a conducting wire, it is going to produce a current itself, or you can say it is going to produce a magnetic field on its own. That magnetic field is going to have a friction, or you can say going to have an interaction with the permanent magnet that is already there. So these two magnetic field is going to produce a force. So this force is going to oppose the change that causes it, the one we call it that is the Lenz's law. So the student has to apply a greater force to keep on rotating, because that force will try to stop the motion of this coil. To oppose that, we have to apply more force, so that that force is going to be cancelled by our greater force, so that it will keep on rotating and produce a certain amount of electricity to allow the lamp to lit. Is it clear, girls, now? Hello, girls. Did you complete the answer? Or you want me to explain?
Yes, would you please explain again?
Okay, do it like this. First you write down, then you can understand it clearly. Due to the induced EMF, a current produced in the coil.
Okay.
Due to the induced EMF, a current produced in the coil, which experiences a force in the magnetic field. Which experiences a force in the magnetic field. Okay.
Okay, miss.
Then it opposes the change causing it. Then it opposes the change causing it. So the student has to apply a greater force on the handle to keep it rotating. So the student has to apply a greater force on the handle to keep it rotating. Okay, girls?
Yes, miss.
Okay, girls, tell me one thing. I haven't seen Maisha in my class till now. Is she joining the online classes? Maisha. Do you remember Maisha?
No, miss.
She's not joining the classes.
No.
Why? Isn't she aware of the classes that's going on?
Miss, she is, I think.
Okay. Then what to do? But
I remember her joining the first few days and then I didn't see her.
okay, fine.
I'm not sure about any physics.
Class, but she did join in one of the math class and English class, I guess. And then I didn't see her.
Okay, fine. What to do? Because I haven't seen her till now in my class. That's why I'm asking. The others I found once or twice in my class. Okay, what to do? Now, guys. So is
Good
it done?
morning, teacher.
It's good afternoon, dear. How are you, Nihat?
Okay, good afternoon. Fine.
Oh,
Alhamdulillah.
so we are doing 41B to 19, and we are in question number 9 now. But you're late to my class 20 minutes. I started my class sharp 12. But Nihat, we need to be serious because we don't know what's going to happen day after tomorrow. Because tomorrow we were supposed to get some
Oh,
information.
teacher, mom. My mom was talking.
Okay, what to do? Now let's continue question number 9. So all of you, those who are following me, check question number 9. It is about that Rutherford's gold foil experiment. I want you to read the
Yes.
question and tell me the answer yourself because you have gone through the procedure many times, so you know the answer very well. Okay. Now all of you read the question. They have given us a diagram. There we can see that there's a gold foil in the middle, a gold sheet, and then a beam of alpha particle is passing through it, and the whole system is in vacuum, because we know that without vacuum this procedure cannot be conducted. And then we saw that there's a detector which is rotating around it in a circular path, and they found some of the alpha particles in certain location. So they're asking, state and explain what can be deduced from the following observation. Number one, they found the majority of the alpha particles pass through the gold sheet undeflected and are detected on the far side. Okay, so what can be the deduction? Means what can you say about it by understanding or by observing this fact that the majority
Alpha particles pass undeviated.
it is already written there, dear. So why will you write it again? That is
So
the
am I supposed to give an explanation for this?
explanation will come later. But what is the deduction? Why all the alpha particles or most of the alpha particles were found on the other side? Why?
Because the nucleus is made up of empty space. I mean the atom.
Nucleus not here, it's atom. So you can write
Atom.
atom is mostly of empty space. Atom is mostly of empty space. That is our deduction.
Yes, miss.
So the explanation will be the alpha particle passed through the space undeflected. That's it. Because it is empty. That's why it will go straight. The alpha particles pass through the space undeflected. That is your explanation. Okay. Now check part 2 of the question. A small number of alpha particles are deflected as they pass through the gold sheet. So they say a small number of particles. So what is our deduction?
Because they were close to the nucleus and then they get deflected by the positive nucleus.
Yes, but why will it get, even if it is close to the nucleus, why will it get deflected? Is there
Because maybe the alpha particles are carrying negative charge.
huh? What are you saying? Alpha particles always carry positive 2 charge, plus 2 charge. Why
So
will it
positive
carry?
and positive, they don't, I mean, they repel and so they deflect.
Yes, so our deduction will be nucleus is charged. That is our deduction. Nucleus is charged. Okay, you can write positively charged, your wish, no problem, because our explanation is alpha particle is charged with positive, or alpha particle is positively charged, so it experiences a repulsive force. So you can write down in the deduction, nucleus is positively charged. Then the explanation is alpha particles is positively charged, so it experiences a repulsive force. Done, guys? Okay.
Yes, miss.
Now come to part 3 of the question. A very small number of alpha particles are deflected through very large angles or return back the way they came. What is the deduction?
Because they hit the nucleus and nucleus is heavy enough to, how do I say,
Yes. Okay.
to send them back as they came or
Yeah,
something.
but you are close. The deduction will be nucleus is very small in size and dense. Nucleus is very small in size and dense. Okay. So the explanation will be when positive alpha particles falls on tiny nucleus, it bounces back. Right? When positive alpha particle falls on tiny nucleus, it bounces back. It bounces back. That's it. Okay. Now, I want you to turn the page and check B. A beam that consists of alpha and beta both, okay, is passed through a region of space where there is a magnetic field perpendicular to the direction of the beam. Okay, perpendicular to the direction of the beam. State 2 ways in which the alpha particle differs from that of beta particle, which the deflection.
Alpha particle deflects downwards and beta particle deflects upwards. Or we can say beta particles show much more greater deflection than alpha particle.
Yes, you can say that, but the first one that you said, down and up, will not say like that. We'll say in opposite direction. Okay,
Okay.
because down and up depends on the direction of the magnetic field. So it's better to say in opposite direction. Alpha and beta particles have deflection in opposite direction. You'll be saying like that. And the other one you can say that alpha particle shows smaller deflection than beta particle.
Yes.
Hmm.
Miss, how do I say it again? They show opposite deflection. What was it? I missed it.
Alpha particle and beta particles shows deflection in opposite direction.
Okay.
Shows deflection in opposite direction.
Thank you, Miss. Done.
Okay. Now, girls, tell me, shall I go to 42 variant? 42,
Yes, Miss.
May, June 19. Do you have with you? All of you check it quickly so that we can start 42, May, June 19.
I'll take a minute to download it.
Okay. So by the time the rest of the girls listen to me, as you know that you are not going to have the exam by the time you came to know about it, but even though I feel that you should still continue studying at home.
I'm doing that, Miss.
Yes. Okay. What about the others? Are you continue to study at home?
Yes.
Okay, fine. Because you know, one more thing is there. Hopefully, you'll be joining A-level, right? So you will see there that in A-level also, whatever syllabus we are having, that is very close to our IGCSE syllabus. Most of the topics will be repeating here with some extended ideas. So if you are strengthening your idea of this level, it will help you a lot in the A-level. You'll see all the motion graph equations you'll be getting there again. You'll be getting equation of motion, motion graph, nuclear physics, almost everything you will continue there. Thermal physics, there you'll be getting the specific capacity, latent heat, everything again, but with some extended ideas. Means the same topic with some other more included ideas you'll be getting there. So it will be really good for you if you strengthen your knowledge about physics at this moment. Okay.
So I should basically stop studying physics and chemistry.
No, you shouldn't do like that. You do it. You keep on studying. And you heard about all this, right? That what is your idea? What is your plan? Means as Nureen, you are talking to me, I'm asking Nureen, what is your plan for? Because they said you have an option to withdraw or to go for the exam on October, November, or you'll continue this procedure that is going to be there after this.
No, I'll continue with this. I'll not wait till October, November, another 6 months. That is
Okay.
total waste of time.
Okay. And that means whatever score is there for you, because we are also not sure about the criteria, let us get it then. After that, you can decide if you are not scoring very good result in any of the subjects, you can repeat it in October, November. Right? So that can
But
be,
then I don't know. Well, British curriculum, the Cambridge said that they would let us know their decision on 7th, and the school, they gave us the school, they gave us time till 7th only to make our decision there if we want to withdraw or not. So
yes.
why?
And
So we would decide that
Well, the withdraw time is till 17th
no,
of
not
April,
17.
but then the school has told like 7th. I don't understand this thing as well. Because I think it should be better that if we get more clear how they're going to grade us or how they're going to judge us.
Actually,
Yeah,
and
that would
also,
make
no,
us
listen,
Yes.
as a teacher also, we didn't get any criteria from the British Council. We are waiting for that. But as they say, you
This is
follow
another thing I have like things with, like even the teacher doesn't know that how they're gonna grade us. That's really weird.
No.
Anika, wait for tomorrow.
Anika,
Or like day
ma'am.
after tomorrow,
listen to me,
7th.
listen.
I'm waiting.
Yes.
What I am saying is they want a decision till tomorrow, and for like till now, like I'm just decided that I'm not gonna withdraw. But
Okay, that is your decision, and you have to wait for the information from the British Council as well
Miss,
as
I
we are
was,
also.
I was,
I'll just react according to that. That's it.
Yeah, that's it. So
no,
listen.
I was
Hmm.
expecting the school to, extend the time limit for 2 more days or 1 day, because we actually need to decide on based on what they say, based on what Cambridge says, we need one more day to decide, and they gave the
No,
same date. I don't know why.
no, dear, listen to me. If you have decided already that whatever is going to happen, let it be. And then if it is not up to your level, you have the chance to repeat the exam on October, November, right? So let us follow the instruction that is coming to us from the British Council, and let's see what happens afterwards. Okay, guys, but my suggestion is to you that just keep on studying, whether you study the Cambridge A level or you study the edX level. In both the cases, you have to go with the same syllabus, almost the same syllabus. Only the pattern of the question gets changed, nothing else. Yeah? Physics, whatever the topic they are teaching in Cambridge A level, we are having the same in edX level. So nothing to worry. But as you are studying this IGCSE level, you will see that the circuits and whatever there's potential dividers and all this that you are learning with me, like the arrangement of the resistance in series and parallel circuit, all you'll get it again in 11. But with some more equations, more extended ideas and all this. So nothing to worry about. You just keep on studying.
It's like just physics in A levels.
That is up to you, dear. We cannot say anything. It's up to you. You have to decide which are the subjects you'll be taking and how to improve yourself over there. It's up to you. You have to decide your mind, inshallah. Okay. Now, yes. Now, listen. Okay. Actually, Sanjita dear, I don't have any other suggestion for you. My suggestion is that if you decide not to withdraw, then you can just wait and you have the option to repeat. And if you want to withdraw, then the whole exam you have to write again. But one more thing is that we are also not sure whether
I'll react according to the news, like after knowing how they will do.
exactly.
But for now, it's a no.
No. Listen, one more thing is that we don't know actually what is going to happen after 2 months or 3 months. Whether the world will be or the earth will be cooled down due to this COVID-19 and all. They're very much uncertain, right? So
Yes.
precisely we cannot say anything. So you just follow the instruction that is coming to you from the British Council and all, and you always have an option, right, to repeat. Or just imagine someone gave the exam in May, June, and they scored D in physics. So what that particular student will do? Definitely, he or he will try to repeat the exam on October, November, and upgrade her or his gradings, right? So you can consider yourself like that also. So let's see what comes up. After that, you have the chance to improve, isn't it? Okay, fine. Let's go for the 41 to May to 19, guys. But always remember, my best wishes are with you all the time. And anything you need
Inshallah,
to,
miss.
yes, anything you need to ask me, discuss with me, we can discuss. Because I as a teacher also, we never came across this type of situation before. So we are also waiting for the instructions, what's happening. We are also in a dilemma, what to do, how to do, and all this stuff. Inshallah, we'll be having some particular criteria and particular instructions from the authority. And we are going to follow it, inshallah. Okay, guys. Now, I hope you have 42 May to 19 with you at this moment.
Yes, miss.
Okay. So, all of you check question number 1. It is regarding the motion graph. A bus is traveling. Okay. A bus is traveling between the points A and D. Okay, guys, I have less than a minute, so just check as soon as it will be over, I'll give it a new link. Okay. All of you look at the diagram, then we have to go for question number 8. There we have given us some instructions, and we have to just fill the gap with those words. Okay, so between A to B, what is happening? If you just look at it, it seems like it will be decreasing acceleration because the line inclined to the time axis. So it is decreasing acceleration. Did you understand? How did I come to this conclusion, girls?
Yes, miss.
Yeah, fine. Now from B to C.
B to C, it's constant acceleration.
No, dear, constant speed.
Oh, okay, sorry.
Yeah, it is a constant speed. Then from C to D. Welcome back, girls. Let's start again. Yes, I was doing that question. It was 42 May to 19, question number 1. Okay, and we were doing A3. Between C and D, that was constant. C to D. It was actually...
C to D, it's decreasing acceleration?
No, dear, I will not say that. Already we mentioned decreasing acceleration one time, we cannot use it twice. So it was supposed to be deceleration, but we don't have any other option, so we'll go for constant acceleration. Because after doing the calculation, I'll be getting minus, so it will be deceleration. So I can use that term.
So, Miss, how is it from C to D? How is it constant acceleration? Because we're decelerating, right?
Yes, but if we just look at the options they have given to us, we don't have any other option. It will be.
But we can use decreasing acceleration, can't we, Miss?
No, twice you cannot use the same. It has to be one time.
But for A to B, we took increasing acceleration.
A
right?
to B is decreasing acceleration because it was
Why?
to the time axis. If it was inclined to the speed axis, means y axis, then it will be increasing. Now it is decreasing. Inclined to the time axis or x axis. That is why.
So it's because of the speed time thing.
Yes, yes, definitely. So you go
Okay.
for constant acceleration one more time because deceleration is not there, so leave it like this. No problem. Okay. Now look at the next part of the question, part B. The average speed of the bus between A and D is 23 km per hour. Okay, fine. Then calculate the distance between A to D. Okay. Here we'll not use any equation because it's a calculation, okay? They are not asking from the graph. So we'll be just writing it. We know the formula that speed equals to distance divided by time. So distance equals to
so speed into time.
Yes. So
Miss,
here,
which paper are we doing right now?
42 May June 19, question number 1.
Okay.
Oh. So there, you got the speed, they say 23, and okay, girls, just check one thing. A to G, what is the time actually here?
Is it 0? Not really, it's 40, I guess.
A to D we're talking about. So that is 2 minutes only. It's 2
minutes. Oh, yes, right. It's
but you have, listen here, you have to divide. You have to divide by 60 because the unit of the average speed is given in hours.
Should be in seconds.
Hours.
Should be in hours.
That is why 2 divided by 60. We are going to hour now. Okay. Then if you do the calculation, just have a look how much it comes out. See 23 multiplied.
It is 0.77.
Okay. Yeah, we can go for 2 dp, 0.77 kilometers. Yeah, that is correct. Now, there has to be a diagram. This is the bus stops at, the bus stops at D for 1 minute. So, you'll be drawing a straight line till 3 because 1 minute it is at stop. Okay, then it travels at a constant acceleration for 30 seconds. Okay, and on the ground. Okay, so let's do it like this, constant acceleration, but they did not mention about any acceleration value, nothing. So we don't need to, we'll just do one thing. You'll be drawing a straight line from 2 to 3 minutes, and then 3, after that, look, 4 we have, and in between there's a middle point, that is 3.5 minutes. So they say for half second, half minute means 30 seconds. So from there, place the scale and just go up around any point and put a dot there and then join that point to 3. Means from 3 it will go to a straight line, but it has to be within 3.5 minutes. So you place a scale on 3.5 minutes. Okay, you place a scale on 3.5 minutes. Then you just go up, just put a point there and write down Y. Because on the question they said you have to label the point Y. And then join Y to that point. X means the previous point, that was X. But the label X when the bar starts to accelerate means at 3. At 3 minutes it will be X, and from there you just place the scale straight up on 3.5 minutes and put a mark or a point as Y and then join X and Y. So it will be a straight line from X and Y, but it will only extend within 3.5 minutes, not more than that. Okay, guys?
All right, miss.
Okay, fine. Now, let's go to the next part of the question. Okay, we don't have any other part in this question. We'll go to now number 2, that is 42 May to 19, question number 2. Okay, now, okay, there is a question regarding a model fire engine. Its brakes are applied. Okay, So it's not moving now. It is just going to apply water. So 0.80 kg of water is emitted in the jet every 6.0 second at a velocity of 0.70 meter per second relative to the model. Okay. Calculate the change in momentum of the water that is ejected in 6.0 seconds. So momentum, what's the formula, girls? P equals to?
MV.
Okay, P equals to mv. So the mass is given as well as the velocity. So you just multiply and get the answer.
0.58.
58, unit, Adina?
Kg meter per second.
Okay, or Newton second. That also you can write. Both the way it will be correct.
Okay.
Okay, fine. Then, and do remember
Newton second.
Newton second, not per, ns.
Okay.
Okay. Now, in part B of the question, calculate the magnitude of the force acting on the model because of the jet of water. Okay, we know the formula F equals to mv minus mu divided by t. Do you know the formula, girls? Yes. Why didn't you use that? Yes. So already you found mv is 0.58 and minus 0. Why? Because the water initially was having a velocity 0. U becomes 0, mu completely 0. So 0.58 minus 0 divided by the time was 6 seconds. Yes.
So 0.096 Newton.
Okay, fine. Done. 0.096 Newton. Okay. Now they say the brakes of the model are released now. Okay. State and explain the direction of the acceleration of the model. Now, girls, they took the brake off. So, what do you expect the model to move? Which direction it will be accelerating? What is the statement? Which direction it will be accelerating? Could you tell me? Yes, girls.
Towards the right.
Right, you say, or why don't you just follow the diagram? Means if you just look at the diagram, the water is going forward, right?
So we say forward direction.
No. Oh, understand it.
Backward.
It will go backwards. The water is going forwards, it has to go backward. So backward acceleration.
Okay.
Okay, and what is the explanation? We have to say, do you remember a question we
It
did?
gives a backward force. The water gives a backward force.
Yes, yes. Water force, because when the water is going forward, it will produce a backward force that causes the this model to go backwards. Okay, so water force gives a backward force which causes the acceleration in the same direction. Because backward force is going to create a backward direction, backward acceleration. Okay?
Yes, yes.
And now come to the next part of the question, that is D. They're saying in C, means in C when that brake is released, what happens? The model contains a water tank which is initially full. State and explain any change in the magnitude of the initial acceleration if the brakes are first released when the tank is nearly empty. Okay, now just tell me one thing. When this model was filled with water, means the tank is filled with water, what happens to the mass of this particular model?
Increases.
Yes, that is more mass, right? When the water keeps on released, then that time the mass of the particular vehicle or this particular model is going to decrease. So when the mass is getting decreased, what do you expect the acceleration to happen?
Acceleration increase.
Acceleration, of course, because mass and acceleration are inversely proportional to each other. So our statement will be magnitude of the acceleration increases. They're asking us the magnitude. So magnitude of the acceleration or magnitude of acceleration increases. Or you can write acceleration increases. No problem. Both the way to be correct.
Okay.
And the explanation is like that, as we said, we'll be writing the equation F equals to MA. No water in the tank. So the reduced mass will increase the force. Reduced mass because the force did not change, right? So force remains the same, mass got decreased. So definitely acceleration will also increase. Okay. Done, guys?
Yes.
Okay. Now let's proceed to question number 3. It is about a solar panel that is generating electrical energy. So all of you look at the question and then we can proceed. Take the main form of energy transferred from the sun to the solar cell for the generation of electricity. Okay.
Heat energy.
From the sun, we straight get heat energy, or which one we get first?
Don't we get light?
Yes, light energy.
Light energy.
First. Yes. So you have to mention light
Solar
energy.
energy.
Yes. No, light energy will be good because light is along with that heat energy is coming, and altogether it's becoming solar energy for us. Okay, fine. So now, yes, now you just check the next one. Consider the generation of electrical energy by a large number of solar cells as shown in the figure. Okay, number 1, they say, state one environmental advantage and one environmental disadvantage. So what is the advantage you want to write there?
Advantage would be no pollution or air pollution.
Okay, as well as you can say, the pollution that we get from most of the electrical power station is that we get lots of greenhouse gas, right? Pollutant gas. Okay, that is also not there. So you can write no air pollution by the emitting gas, polluted gas emission. That can also be there. Or just you can write no air pollution, no problem. Both the way it is fine. Because it is not creating any pollutant gas or not releasing any pollutant gas to the nature or to the environment. Okay. What is the disadvantage you can say?
It's huge and it takes up large space.
Yes.
So which it takes up land and reduces biodiversity because no species can travel over there. It's only solar.
We're not speaking about bio here.
Will not go to that extent. We can just say huge land is occupied as well as it can cause visual pollution. Means you cannot see anything.
Visual pollution.
Yes.
So it's bio again.
Yes, but then also, but it is going to block our vision. So we cannot see anything more after this. So we have to say it can cause visual pollution and huge land is going to be occupied. That is the main problem here. Yes. Now,
because they are huge.
Yes. State and explain whether the source of electricity is renewable.
Yes, it is.
It is renewable because it is coming from the solar energy. So we can just mention it is renewable. Yeah. Now there's a calculation. It's regarding each group of solar cell is having
Efficiency.
the solar cells are situated in a region where 260 watt of solar energy is received per square meter of the cell. Okay.
Total input voltage by total output voltage by input voltage multiplied by 100, right?
Voltage will not go, it will go for the power because they have provided power in the past. So power output by power input multiplied by 100. But first we need to calculate power in and power out. Okay. If you just look at it, power in will be the area of a group of cells is 1.2 into 2.8 multiplied by 260 because 1 meter square is giving us 260. Then you get do this calculation that is 1.2 multiplied by 2.8 multiplied by 260. Then it comes out how much?
873.6.
Okay, 873.6 watts. Okay, now power output.
873 minutes.
Okay, 873.6 watts. Then power output will be, see, they say 2.5 ampere current is coming out with a voltage. So P equals to VI. That formula I am using here. So 2.5 multiplied by 86. Then check what is the?
So 215.
Okay, 215 watts. Okay, guys. Now come to the part efficiency. We'll be writing the equation. Efficiency equals power output by power input multiplied by 100%. Because for the equation we'll be scoring 1 mark, 4 mark question. Okay. So you just place the values now. It will be 215 divided by 873.6 multiplied by 100.
So it comes to 24.6.
So 24.6%. If you want, you can continue with 25%. But you can leave as 24.6 also, no problem. 24.6%. So the percentage, that is the one we got, that is actually giving us the efficiency of this particular solar cell. Done, girls?
Yes, miss.
Okay. Now I want you to proceed to question number 4. 42 May to 19, question number 4. Check. State and explain in terms of molecules any change in the pressure of the gas when the volume is reduced at a constant temperature. Okay. Now look, constant temperature. So whenever you see constant temperature, which law comes in your mind, girls?
It's Boyle's law.
It is Boyle's law. It is Boyle's law. So in Boyle's law, what do we say? How do pressure and volume relate each other?
Directly proportional.
No, yeah, they are not directly proportional.
Inversely proportional.
Inversely proportional. Yes. So they say volume is reduced. So what do you expect the pressure to become?
Increasing.
Yes. So you'll be writing the statement, pressure increases. That is our statement. Pressure increases. Now, explanation. So as we learned before, I think before also one of the questions we were given is, as the volume increases, here volume decreases. So as the volume decreases, number of molecules in certain area increases. They hit each other and the container wall more often than before with greater force. They hit each other and the container wall with more force and more often than before. And force per unit area is pressure, so pressure increases. Force per unit area is pressure, so pressure increases. Okay? Now, check part B of the question. Any doubt, girls? I don't think so, right? Fine. Let's go for
Expands most is gases
Mm-hmm.
and expands least solid.
Fine. That's it. Now you just take the next part. Question number 5 now. A liquid is heated so that bubbles of its vapor rise to the surface and molecules escape to the atmosphere. Take the name of this process.
Evaporation.
Mm-hmm. Wrong.
Evaporation.
No, wrong answer.
Why wrong?
Okay. A liquid is heated.
A liquid is heated so that bubbles of... Wait, it's boiling.
It is boiling.
Boiling.
Yes. So write down boiling.
Gas. Boiling.
Mm-hmm. It is boiling. Then at a lower temperature than A1, molecules...
Now it's evaporation.
Exactly. So you have to understand it. So don't rush into conclusion. Read the question, check all the information, then you get the correct answer. Fine. So the first one is boiling, second one is evaporation. Now come to B1. Okay, they have given us some information and actually that is the procedure.
E equals MC delta theta.
Okay, and there's a heater is used. So how will you find out the energy provided by the heater? What's the equation? E equals to?
Here energy equals P. We're finding power.
Yes.
P equals E by T.
Yes, but you
First we find the energy by MC delta theta and then we have the time.
listen. Let's do it together. First, to write down the equation E equals to MC delta theta. Then in place of E, I can write PT. PT equals to MC delta theta. Then rearrange P equals to MC delta theta divided by 2.
Oh, we can do that?
Yeah, why not? Rearranging the equation is always there. And then you just substitute all the values and you get the answer. And waiting, you just do it.
So
final equation becomes, okay, you have to show the steps, guys. Otherwise, 4 marks. So 2 marks will be there for you. So you'll be writing first of all.
Are we doing it's like first we find energy by doing MC delta theta and then we divide E by T to find the power?
No. Listen to me. You'll be writing E equals to MC delta theta. Then PT equals MC delta theta. Then P equals to MC delta theta divided by T. Then you substitute the values.
But miss, that means the same thing what I said. It's just I made it healthy and
listen to me. Our point is that you have to rearrange the equation. For this rearrangement, you will be scoring marks. So let us do it like that.
Okay.
Then substitute all the values and just see what comes up. It is 2.7, that is the mass, multiplied by 900, multiplied by temperature rises here, 39 minus 21. Okay, and then time t is 2 minutes. So 2 into 60, we are going to the second, then plus 30 also. 30 seconds is also there. So 2 into 60 plus 30. Yeah, what's the final answer now? Okay.
Miss, the final answer is 291.6 watt.
Yes. Okay. Since we are finding out the power, so we can write down 291.6 watts. Done, guys?
Yes, miss.
Okay. Now come to part 2 of the question.
It's insulation around the block,
Okay. Now
around the metal block.
Mm-hmm.
And the explanation would be to avoid the loss of thermal energy to the surroundings.
Okay. Correct. No problem. It's correct. Now you have to go to question number 6. Okay, guys, as we don't have that much of time, we have only 2 minutes. Let's do it quickly. The first page, that is 6A. They say, what is the name of the process?
Ooh, who is crying?
Nihat, is that your youngest sister or brother? Okay. Now, girls, what is the name of this particular process that's happening in water? Refraction of water wave.
Refraction.
Yeah, fine. Done. Now, quickly check. Suggest the cause for the change in the direction of the wave.
Because it is moving from shallow to deep region.
Yes, but we have to mention, we'll not say shallow to deep, we'll say change of depth.
Change
Okay.
of depth.
Yes, change of depth of water. Then you can mention, but here they mention here, okay, by looking at the diagram, we can understand that it is moving faster in the region B than in region A. It is moving faster in region B than in region A.
Okay.
Yes. Okay. Now quickly come to the other side. Okay, here you have to draw. They say draw a wave which is half the amplitude and a greater frequency than the wave shown. Okay, half the
it will have a smaller head. I mean the
amplitude they said. So you do one thing, you have to measure the amplitude, whatever you will find on the diagram that is given to us. Divided by 2 and then draw 2 lines above 0 and below 0. Then you just draw another wave which should have a it should have less wavelength but more frequency. You can measure like 1 centimeter, 1 centimeter apart, put a mark and then quickly draw. Okay, do one thing, draw this afterwards. If you are not done by the time, then you go to C. Question number C. A train travels.
That's speed by frequency, like wavelength equals speed by frequency.
Yeah, that is the calculation. But what about the explanation in the first place?
Oh, acha, I didn't see that. Train travels along steel rails. A person waiting at the station hears the sound of the train through the rails before he hears the sound of the air. Because speed of sound is, what is it again? Sorry, just
speed of sound is more in solid than in air. That's the answer.
Yes, that's right.
Okay, so let's do one thing, girls. As the time is up, we are going to stop today. Tomorrow, inshallah, question number 7 onwards, I'll continue. Okay, guys?
All right, miss. Okay, miss.
Okay, guys.
Okay, miss.
Thank you, miss.
And since now all of you are here, I just want to remind you regarding the tuition fees. You saw that notice in your group. Did you inform your parents?
Notified my parents.
Fine.
I told my parents about it.
Very good. All of you should remind your parents because they're not checking this group. You are the one here. So just inform them, and of course, if you need, you can call that person. Give the number to your parents so that they can contact Mr. Saiful. Okay, see you tomorrow.
Okay, miss. Assalamu alaikum.
Walaikum salam. Stay safe and pray for all of us.
Take care.
Okay? You too. Allah Hafiz.
Allah Hafiz.
Thank you, miss.
Thank you.